Today we're going to do a little mental math, get our brains warmed up. Glad that you went like that. I'm going to put a problem up one at a time. I want kids to really think about it. Give your partner a chance to think. When you think you know it, you just put your thumb like this. Everybody try that? Yeah, somebody else, Mr. Decker does this, I know. So I'm going to do the same thing that he does. You're going to put your thumb real low, and that's just our kind of silent signal that says, oh, your kids are ready to share. I'd love to be able to call you by name and get to know you, but I can't if I can't read your name tag. So if it's, in the front, great. If it's in the back, I don't know how I'm going to see that. Thank you. I don't kind of see that on your sleeve. All right. Some of the problems will feel like warm-up problems, and then they'll just get a little more tricky. Is that cool? What were your questions, Lily?
Do we discuss it with our math partner?
Good question. Sometimes we are going to discuss with our math partner, and sometimes we're going to talk about it as a whole group. Totally depends. Okay? Let's get started with mine. Let's try this one. When you have it, put your thumb up. Wow, you guys are fast. Sean, right? What were you thinking? What do other people think? Do you agree?
Yes.
Anybody get a different answer than 6? No? Okay, that was neat. Do you guys have this one? You just know this one? Yeah, I would hope so. That's great. Good. And the kids in New York know that one too. But what about this one? Before you do that problem, I'm going to show you something I have in my pocket that I brought. Before you do that one, I made a little picture of the 2x3. Right? You okay with that? Do you see why I'm calling this 2x3? Okay. So Kobe, will you help me put that one up there? Let's put it up there, because you're going to see what we're going to do with it. Let's put a magnet on it. You got it. Someone help us figure out, why is that a picture of 2x3? Why?
Because you put that equation on the board, and that's like multiplication is kind of like a raise.
It's kind of like a race? How?
Like it's like 2 by 3. Like there's 6 squares in it, and then there's 2 for the length, and 3 for the width.
So you did 2 like this and 3 like that. So there's a 2 in that picture, there's a 3, and where's the 6? Oh, John, what did you do?
The whole thing.
The whole thing is a 6. Okay, so keep that one in mind. Will you do this one now? 2 by 30? When you have it, just put your thumb up. Well, before you tell us the answer, will you imagine, I have it in my pocket, you can see it sticking up. I made a 2 by 30. Will you think about what that would look like? Think about what that would look like? Okay, now I'd like you to turn and talk to your partner. Say how you solved it, and then think about what the array will look like. In a minute, we'll check and see. What's the answer? What's the array going to look like?
Because 30 plus 30 equals 60, so you double it. Yeah. 2 times 30 is 6. Yeah.
Who wants to share how they're thinking about 2 by 30? Elias? What'd you do here?
Well, so on the first one, I kind of think of that times. Like if I turn it, it's like 2 plus 3, that equals 6.
Say that again. 2 plus 3 is 6?
Well, it equals 5, but plus 1 more equals 6.
Okay. And how would that help you here?
Then it's kind of like saying that you're just having 2 30s that equals 60.
2 30s. So did you do a 30 and another 30? So that's one way to think about this, is a 30 and another 30 makes, you said?
Makes 60.
Makes 60. Okay, that's a nice way to think about it. Amy, you do it a different way? What do you do, Dalen?
Since that's the since 10 times 3 equals 30, then all you have to do is add the 0 at the back of the 6. And the ones.
So you're saying this is really the problem. 2 and 3 is 10? Is that what you said? 3 times 10 is 30? And you said that's just this problem with the 0 on the end? So that's interesting. So you're saying we already did that problem. It was 6 and then put a 0 on the end? Can I think of it like that? Are those the same?
Yes.
Who's convinced that those are the same? 2 times 3 times 10 is the same as 6 times 10. John, you think those are the same? No. Who thinks they're the same? Logan, you do? Can you convince us those are the same? Try it.
Because 3 times
said 3 times 10 is 30. Is this also true? 3 times 10 is 30. Will you try to talk to your partner about, is this whole sentence true? I'm not sure anymore. John's not convinced, right? Just try and talk to your partner about it. Is this the same as this? Is the same as that? How do you know? All right, come on back, everybody. Who can describe something really smart? Oh, wait, you don't even know what the question is. How you have your hands up? I'll finish my question, then you might. Who can describe something really smart that your partner said? There are no smart partners in this room. What? Willie, tell us what Lily said.
She said like that we already know that 2 times 3 is 6.
We know that's 6. Okay.
So and we just have to.
You said this part is 6. So you can think of that as. Oh, that's. Keep going.
There's already the 10 there, and so 6 times 10 is 30. And
6 times 10 is.
6.
That's what I thought you meant. Okay. 6 times 10 is 60. We knew that.
And 2 times 30 is 60.
Okay.
So we all know the same.
And that helped you what she said. Yeah, she put a little. She grouped them. Anybody else have a smart partner? Ethan, did you have a smart partner?
Well, he said that since 2 times 3 equals 6,
Yeah.
you can do 6 times 10, which equals 60.
Okay. The other thing I asked you, Jalen, you want to jump in there? This was your original idea.
Yeah, Sean, he said, since all you have to do is add the 0 at the end if it's a 10.
Add the 0.
Put the 0 in
Really
the
saying
ones
put
place.
the 0.
Put the 0 in the ones place.
This seems like a trick you guys all know.
Yeah.
So Sean, you said I just put the 0 at the end? What do you mean by that? Put it in the ones place. Okay, so you're saying I can use this problem, and then I just do it again, but I put a 0 in the ones place, and that's my answer? No. Anybody else know what Sean and Jalen are talking about? Megan, what are they saying?
Well, this when you tell us if you just add the 0, it's just like adding.
I gotta meet this teacher. She just said add the 0 at the end. It's so weird. Because when I add a 0 to a number, like 2 times 3 is 6, and I add a 0, I get 6. And you guys are telling me this answer is 60. What's going on, Audrey?
You put the 0 at the end.
Why?
Because if you add a 0, it'll be the same.
Okay, but I'm still not sure why you put the 0 at the end. Can we explore that a little bit on the array? Let's see what that means to put the 0 in there. You guys are supposed to picture what this 2 by 30 array looks like. Who wants to describe it to us? What does it kind of look like? It's in my pocket. I'm going to take it out in a minute.
10 times as much as that 3 by 2 array.
Say that one more time.
10 times as much as that 3 by 2 array.
Can you use your hands to describe what it's going to look like? Like 10 of these? Is that what you're saying? How do you see your name? Yoon So is saying 10 of those is going to look like the array that's in my pocket. What do you think of that? You're nodding. You're nodding. Megan's nodding. Lily?
You can also go that way, but turn down that way.
You think it's going to go like this?
Or that way.
Or that way? Interesting. What are you thinking?
Well, I think it's gonna just be like 2, and then just like 10 times as it. It's just like it's gonna be the same, except it's just gonna be 10 times it.
Should we check? Okay, so Yoon So, am I saying your name right? Let's see if that's true. Ready for the 2 by 30? Should we unroll it? Here we go. Whoa, it's like Santa's list. It's pretty long, huh? Let's put it up and see if this is true. Here we go.
Kind of looks like a timeline.
Does it look like a timeline?
Yeah.
That's cool. I never thought it was that way. Let's put one there. Okay, I'm going to put one there and one there. Kobe, can I move you for a second? Because I don't want to step on you. Yoon So, you're saying 10 of these will fit into here?
Yes.
You're sure?
Yes.
Want to come up and count with me? Okay, will you be my counter, my class counter? Let's count them, because I didn't bring 10 of those. But could we mark where they would go?
Yeah.
Okay. All right, I'm going to give you this big old pink pen, and we can use this one as your measurement tool. Alright, to help you know. And would you guys count along with us? How many of you think there's going to be 10 of these? Anybody think there might be 9 or 12? 8? John, you're not sure? Okay, we'll check. Okay, count along with us. Here's 1. You want to make a line like right there? 1, 2, 3, 4, 5. Is it going to work, guys? 6? I don't know.
7, 8, 9, 10.
Wow, what a prediction. That's pretty cool, huh? So there's 10 of these that fit into here. 10 2x3s is the same as a 2x30. That's pretty cool, huh? Interesting. All right, use that idea. I didn't bring any more arrays because, man, I don't have that many pockets and that was big already. But use that idea and see if it'll help you do this problem. I forgot. 2 times 14. Think about what that would look like when you have it, put your phone up. Can't see your name. I'm calling it Jeremy. What are you thinking?
28.
How do you know it's 28?
Well, we can just add 14 again.
What do you mean again?
Like, use addition.
Add 14 and...
plus 14.
Okay, so Jeremy's thinking that if you do 14 and 14, that'll give you 28. What do you guys think? Okay, anybody get a different answer than 28? No? Okay, what are some other ways to think about it? You did it a little different. Cody, what'd you do?
4 times 7.
4 times 7. Ooh. Why could you do the problem 4 times 7? Are you saying this? You're saying that instead of doing 2 by 14, I can make the problem 4 by 7? Those are the same? Is this an easier problem for you? Which do you guys like better, this one or this one? You like the first one, but Kobe over here likes 4 times 7. Turn and talk to your partner about how he knows that you can make it into 4 by 7. Alright, let's talk about this together. Anybody think that you agree that 2 by 14 is the same as 4 by 7? Lillian, what do you think?
It's the same because if you add like 7, since it's 4 sevens, if you add 2 sevens together, that'll be 14 and 14 plus 14, that equals 28.
That's enough. You said there's, if I think of these as 4 sevens, right? You're saying 2 of those together would make 14? So I can think of this as sevens too, huh? But then that makes 14. There's my 2 14s, and there's my 4. You're saying these are the same. Let's draw an array of that. What do you think a 2 by 14 will look like? Can you describe it to us? What do you think? 2 lines of 14? Alright, I got that. We can do it like that. Something like that? And you're saying this whole thing is 28? What if we wanted to show that it's also a 4 by 7? Audrey, what would I do?
You would make it kind of like push the sides in and make it kind of like a square.
Like push the sides in and make it like a square. What do you think of that idea? Ethan, you like that idea? Okay.
Then you could just put one side
You're saying I can cut this in half?
and you put one side of it.
What do you think of what Ethan said? So Audrey said I could just smush it, right? And you're saying I could cut it in half. Why did half make sense to you?
Because 14 is 7.
Half of 14 is 7.
And then if you add 2 to the diagonal,
That's kind of cool. Should we try that? All right. So when you say halving, do you want me to cut it in half this way, or do you want me to cut it in half this way? Turn and talk to your partner for 30 seconds. What do you think? Do you want to cut it in half this way or this way? All right. Logan, what'd you guys decide back there? Which way should I cut it in half?
up and down.
and down, why did that make sense? Just easier? Does it make sense? Is it Chava? Ava.
Because if you were to cut it in half this way and put it on the bottom, it would be the same thing.
Oh, good call. You're saying if I slice it this way and just move this down here, it's going to look the same. It's like, wow, Sin, why would you do that? Okay, so you're saying I cut it in half here, and now I have two arrays. What are the dimensions of this one? What do you think?
2 by 7.
It's a 2 by 7, so I'm going to put a 7 here. And what are the dimensions of this one? What do you think of Parker?
7.
Also a 7? Okay, and then you said there's going to be a rearrange. Oh, you want me to rearrange?
You'll move 1/2 to the bottom of the other.
Move this down here? Alright, so I'm going to take this 2 by 7 and put it down here. Okay, and we'll just label that 2 by 7. So now this is my new array. What is that new array? What is that new array? Chelsea, what are you thinking? Can you say nice enough? So it's a 4 by 7. She said 4 on one side and 7 on the side. Very cool. All right, let's do another one. How about this one? Put an 8 in the sleeve. This one's a little harder, right? So we're going to do another thing. 20 by 14. Go ahead and talk to your partner about how you solved it. Really listen to see how they solved it.
Yeah. It's just like, you know 28 equals 28? I mean 280. Oh, okay.
You don't agree. Alright, come on back, everybody. Oh my gosh, thank you. Lily keeps saying, your markers are open. You're right, your markers. Thank you. You're like my marker police over here. Anybody changed their thinking after talking to their partner? Like you had one answer and then you changed it? What happened?
Well, you can so I know what it is. So if it's 2 times 14 equals 28, then you're just adding that 10 to the 28.
Adding a 10 to the 28, so that would be 38. Right, I added a 10. Megan's laughing. Why are you laughing?
Because it's adding is not. I mean.
What do you think he meant? I knew what you meant. I'm just playing. You're saying I can use this problem to help me with this problem. Is that your idea? And somehow this 28 and adding a 10 to it would help. Sean, is that what you were talking about before? How would you solve this problem?
2 times 14 would be like this thing is 20 times 14. You just put the 0 with it after the 2.
You said put the 0 in the ones place. Like it's almost like the whole number moved over, huh? What are you thinking? Would that work?
Yeah, it's kind of like the same equation, except for the 2, you put a 0 at the end. So then to make the equation equal, you have to put a 0 at the end of the product of the first equation.
So is this equation like this equation? Were these problems alike? How are they different? What's different about them, Audrey?
This one's a 20 and that one's a 2.
Okay, so you're saying there is a 2 by 14 in this problem? There's also an extra 10. So could I write this as like, it's a 10 and 2 by 14. Is that the same? Check that out, how I wrote that. I'm saying, is that what we're saying? I'm not sure. Is this the same as that?
Yeah.
I see people nodding. Hava, what do you think of that? Is that true? Yeah? Okay. And so if I already know this part is 28, what's my answer here? I'm a little fuzzy. What do you think of John?
280.
280. Are you guys convinced? All right. Well, here comes a nice one to get us really thinking and awake over there, Ethan. I see you falling asleep with us. And maybe Kobe and Elias, will you guys help me put this up? Because I think this might help you.
That, and then it's gonna be 20 up here and then 14.
Oh, so you're thinking I do the 20 over here and the 14 here? I could do it that way, right? just to be consistent, I'm gonna flip what you did. I'll put the 20 here and the 14 here. You okay with that? I just turned it? All right, so let me just rewrite that one. 20 by 14. I'll do the flip of what Kaylin said. And I'll put the 20 here and the 14 here. Like that, roughly. And you guys are telling me this whole thing is, what would we say, 280? Yeah. Okay, here's your next problem. Think about this. Got a lot of grumpy faces all of a sudden. Nobody likes this problem, huh? You want me to go back to Brooklyn now, huh? No?
No,
Thanks,
I want
sir.
you to sit.
You want me to stay? More problems coming. Next one is 19 times 14. We're going to need a little time to think. See, some thumbs up and some thinking. Do you want to check in with your partner first? Do that first, and we'll talk about it. How do you think that? Okay, John? Just like introduce the All right, come on back, you guys. Let's try this one. Who haven't we heard from? In a little while. I see you guys. Oh, we just heard from you. You helped us with that array. Anybody have that? Madonna?
Well, it's multiplication is basically like this many groups of like that, like 20 groups of 14. So then if there's 19 groups of 14, it's just one group less of 14. So then you'd have to do 280 minus 14, which is 266.
Did you guys follow that? You guys just did a little fist bump. That's exactly what you did. So, Santana, that was really hard. So 19 groups of 14 is one less group, right? If I wanted to take away one less group on this array, where would I take them away from? And I'm wondering, should I take them away from here, or should I take them away from here? You see what I'm saying? Because I want to try to make a picture of what you just said. Logan, what do you think?
You take it away from the side
Okay, why does that make sense to you?
because 20 is the closest to 19. It's one less.
You're saying I make a cut right here. Just take away one group, and I make this now 19. So how many would be in this one group? What do you think, Logan? 14. So if I took this group away, I got rid of it. It used to be 280. Now it's 280 minus that group. How many is that? John, what are you thinking? 266. We agree with that? Jalen, you cool with that? Now Parker and Ethan, is that what you got too? So you took this many groups and you took away one group of 14. You're saying that's 266. Okay. I'm wondering if we should take a tiny stand and stretch break. Do you have a ritual for just getting our energies up? And then we'll do 3 very quick problems. Parker, what do you think on this one? You think it's 60? What do we think? We agree? We like your answer. Okay. How did you think about it? How did you do it?
Because if you do 3, if you do like 10 times 3, that would be 30, and then just add another 30. And
Let me see if I got that straight. If you do 10 times 3 would be 30, and you're saying do that again? And I put those two together and makes 16. You're saying a 3 by 10 and a 3 by 10 would make a 3 by 20? Is that true?
Yep.
Okay, because we said this is 30 and this is 30. So this is a picture of a 3 by 20. And that's 60. But you said there's another way I could rearrange it. Audrey, what's another way?
Put the other 3 by 10 at the top.
Move it down here. Okay, now Josie, you said something really interesting. I was listening into your conversation. What did you say? now it's a 6 by 10. And you said it's the same answer. Doesn't really matter, does it? Jalen?
It's the same answer, but if you want to keep that equation, if you want to keep it as the equation, you have to do it that way.
Okay. So you're saying if I want to make the 3 by 20, I have to go this way.
But if you want to get the right answer, if you want to get the right answer, then you can do that.
Okay. Are we also saying that this is a 6 by 10? That this 3 by 20 could be a 6 by 10? That's pretty cool, huh? I like this problem better. What do you guys like better? Caitlin, which problem you like better, 6 by 10 or 3 by 20? Me too. Yeah, me too. All right, last problem, and I'm actually going to let you think about this problem, and then I'm going to take these adults and we're going to go talk about your thinking, because it was so smart. So we're not going to solve this one together, but be thinking about how you would solve this problem up here. How would you do 3 by 18? And guess what? I'll be back tomorrow, so maybe when I come back tomorrow.
So you're here tomorrow?
What'd you say?
You're here tomorrow?
I'm here tomorrow. You can't get rid of me.
Classroom?
Yes.
Yay!
It's going to be fun.